Alright, welcome back to another video on my channel, math_exe. And today we're going to talk about how to graph linear functions. And as the name suggests, linear from line is a function that when graphed looks something like this right here. I'll just circle this in back. So this is an example of a linear function. And the standard form of a linear function is written as so. So we have f of x, or sometimes called y, is equal to ax plus b, where a and b are constants and a is not equal to 0, and otherwise it will be just like b, which is just a constant, and it will just be like just a straight line. So we don't want that. Well, sometimes a could be 0 and it would form like a horizontal line. So yeah. Anyways, there are some important things to keep track of when you're drawing linear functions. So the first thing is the slope or the gradient, and I will just explain them in the bottom later. And the second thing is the y-intercept, or sometimes given the x-intercept, but usually the y-intercept is like more famous and more, I would say, more useful. So yeah, we just get right into it. So I'll first explain what the slope or gradient is. So a gradient is a measure of the steepness of a line. So assume that we have a line like so. The gradient will help us to measure how steep this is, and of course this is not I would say not really steep at all, but if you have something like this, and this is a very steep line. So the formula for the gradient is m, which is our gradient, equal to this is pronounced delta y, this is pronounced delta x. And what these mean are the change in the y direction, meaning change in the up or down direction. This will tell us the change in the left or right direction. And usually it will rewrite these as follows. And you may wondering what these x2 and x1 represent. Well, let me explain. So assume you have a line and you have like two random points on the line. I'll just call them A and B. And assume A has coordinates x1, y1. B has coordinates x2, y2. And to measure the gradient, you can just substitute the values of x1, y1, x2, and y2 into this equation right here. Okay, and one thing I want to mention, that the standard form of this equation right here actually has some special properties, and usually isn't written like so, but usually is more known like so. This is called the point slope formula, and this is just basically like a equation in terms of the gradient and the y-intercept. So the equation is as follows. So we have y, or you can call this as f of x if you want, and this is equal to mx plus b. And when where mx is the gradient, and the b is the y-intercept. Okay, And I would quickly explain what the y-intercept is first. So basically the y-intercept is a point of a function when drawn in the xy plane. So assume we have a function like so. We'll just draw it like so. Basically, it is a point where the line or the graph intersects the y-axis right here. And linear functions only intersect the y-axis exactly once. So no matter how steep it is, it will always intersect at some point right here, for example. And you may be wondering how to get the coordinates of this point, certain point right here. Well, you know that when a certain function intersects the y-axis, its x-coordinate will always be 0. So you can just substitute in x equals 0 to this formula right here. So let's say if I do it, we have m times 0 plus b, and notice this whole thing cancels because 0 multiplied by anything is 0, and you get just the equation y equals b. So let's try an example of a function. So we have our function like so, and we want to find the gradient and the y-intercept of this function. So, and possibly the x-intercept, even though I didn't include that, but I'll show you the way anyways. So recognizing our Poinsot formula, y equals mx plus b, and by substituting coefficients, this x must be equal to x, and therefore this m must be equal to 1 over 3. So the gradient is 1 over 3, and the y-intercept, which is the b, must be equal to 3. So yeah, it's pretty simple. And how to find the x-intercept, if you may ask? Well, I'll just move the board right here, back right here. And the x-intercept is kind of self-explanatory, like the y-intercept is just when the line intercepts the x-axis at a certain point. And you know this point has a y-coordinate of 0, so you can just substitute that in and then solve for x. So yeah. So let's see. If we plug in y equals 0, we get 0. It's equal to our original equation. I'll just rewrite it here. And we can just work things out by subtracting 3 from both sides. So this and that will cancel, and this will become a negative 3 on the left hand side, and then 1 over 3x. And then we can just multiply both things by 3 and just put them right here. So this and this will cancel, leaving us with our x-intercept being at, well, I should say the x-coordinate of our x-intercept being at negative 9. And if you want to write this in a coordinate form, we can write this b equals 3. So we can write y-intercept at, we can just write the coordinates. Remember, this represents the y-coordinate. So we have 0 because that's a y-intercept, and the x-coordinate is always equal to 0, and then we have our positive 3 right there. Same thing right here. We can have our x-intercept at, well, in this case our x-coordinate is negative 9, and our y-coordinate is 0 because we're talking about the x-intercept, and the y is always equal to 0 at that point. Okay, and I'll just try to do an example, like probably like what you've seen in like some exams about this type of and recall our Poinsot formula for this. I'll just rewrite this in a red. Recall that y equals mx plus b. M is our gradient, and I'm going to rewrite the formula. And first, notice that we have our x1 value right here, x2 value right here, and actually not x2, this is supposed to be y1. So I apologize before. This is x2 and y2. Okay, so we know our m should be, I'll lower the board down a bit. We have our x2, which is -2. I'll just keep that right there. Alright, y1 value is -3, and this is all over x2, 3, which is 3, and minus x1, which is 2. And let's see if I did anything wrong right there. Looks like I don't. Okay, so we can just quickly evaluate this, and we'll get our gradient of 1. So now we can just substitute our m back there, so we can get our current function y equals x plus b. And note, this is not the correct answer because we still have an unknown right here, which is the b. And you may ask, how do we get this? Because if we like substitute x equals 0, we just get y equals b, and it doesn't really help. So what we can do is we'll just substitute a pair of the coordinates. So let's just try to substitute our a with our coordinates right there, and this is because this point is on the line AB, so yeah, we don't really have any problems with that. So noticing our x1 right here, I mean our x value is 2 and our y value is -3, so I just rewrite that -3 equals 2 plus b, and we can just subtract 2 from both sides, so we can get that b is equal to -5. There we go. Well, this also works if you like substitute another value of the points, the coordinate of a point on the line, unless you did some miscalculations during the whole way. Okay, so our final answer is the equation y equals x minus 5, which is the equation of the line AB. So we can just pretty much calculate pretty much every point on this line, so we can substitute, like when x equals 0, we can get the y equals -5. So yeah, so two ways to find like a function of our equation, I mean the function of a linear equation, is the Poinsot formula. We can just calculate the gradient and the y-intercept, and usually it tells you a graph. So yeah, and another way is just to know 2 points on the graph and then calculate the gradient, and then substituting the coordinates of a certain point on the line, and then you get the formula. So I don't really have too much to talk about this point, so hopefully you guys enjoy this video, and please subscribe for more videos because I will be uploading daily. And as always,